Hi there everybody, welcome to our lesson on time zones. Now if you remember, our last lesson was on latitude lines and longitude lines and how we use them to find locations on the Earth's surface. This lesson is going to concentrate on how we use longitude lines to determine time zones. Now the first thing that you need to know is that a time zone is a region or an area that observes the same time throughout. So no matter how north or south you are in a time zone, you are going to experience the same time. And it's not until you cross over another line of longitude where a new time zone begins. Let's start talking about that right now. Now here I have a picture of the Earth, and this is a bird's eye view. So imagine you're floating in space above the Earth and you're looking straight down at the North Pole. We have our two major longitude lines. We have our prime meridian located at 0 degrees. Remember, the prime meridian is the starting point of all longitude, which is why it's at 0. And then we have our international date line, which is at 180 degrees. Okay, the reason why it's at 180 degrees is because this angle here is 180 degrees, as you may remember from math. So the international date line is located there. This is the end point. There is no higher degree number after 180. As we learned in our last lesson, the prime meridian is going to divide the Earth into two hemispheres. The western hemisphere here on the left, and then the eastern hemisphere here on the right. And that's going to be important when trying to figure out how much time or what time is being observed in a time zone, or how to calculate the differences amongst time zones that we'll get to later. If we take a look, as we said before, longitude lines determine the time zones on Earth. So here are all of our longitude lines, all intersecting at the North Pole as longitude lines do. And don't forget they intersect at the South Pole. So each wedge here represents one time zone. Now each time zone is actually 15 degrees of longitude wide. Here in the Western Hemisphere, we'll notice that all of our degrees are labeled with W's, so we can note that we're in the Western Hemisphere. And then again, in the Eastern Hemisphere, we have our 15 degrees multiples, all labeled East for the Eastern Hemisphere. Now, the reason why a time zone is worth 15 degrees of longitudinal distance is because what scientists did was that they took the total angular measurement of Earth, which is 360 degrees, because a sphere, the shape of the Earth, is 360 degrees, and they took the amount of time it took the Earth to rotate or to spin one complete time. So that takes about 24 hours. So it takes the Earth 24 hours to make one complete spin. So they took the angular measurement 360 degrees, divided it by 24 hours, and what they realized and calculated was that the Earth rotates 15 degrees an hour. So each hour is worth 15 degrees of longitude. So this is worth 1 hour of time, this is worth 1 hour of time, and every single wedge on this picture is worth 1 hour of time. What you have to remember is you have to remember when you need to add hours and when you need to subtract hours, and how many hours you need to add or subtract. So this is how we go about it. You can remember the simple little rhyme scheme, and it'll help you remember what to do when traveling west or east and what to do with time. Now, if you go west, or if you travel west, time gets less. So for every 15 degrees that you move westward, you are going to lose an hour of time. So from the prime meridian to 15 degrees west, I lose 1 hour of time. If I travel to 30, well, that's 2 sets of 15, so I lose 2 hours of time. And if I go from 0 to 45, that's 3 sets of 15, so I lose 3 hours of time. Because remember, 15 degrees is worth 1 hour. So every 15 degrees I travel westward, I lose an hour of time. Now the opposite happens for the east. As you go east, time increases. So for every 15 degrees east you travel, you add an hour. So from the prime meridian to 15 degrees east, I add 1 hour here. And then again, when I go 30, as we said before, 30 is 2 sets of 15. That's going to give me 2 hours. As I go to 45, that's 3 sets of 15. That gives me 3 hours. And I'm going to add an hour for every longitude line worth 15 degrees until I get to the international date line. The prime meridian is usually our reference. So we usually think of that as 0 hours, because that's our starting point, so you can't be any hours different. And your international date line is usually about 12 hours different. Okay? So that's how the direction and time breaks down. Remember, as you go west, time gets less. as you go east, time increase. So let's see how this works. And to do that, what I'm going to do is I'm going to eliminate these green and purple boxes just so it doesn't get too visually busy for us. So let's say in this time zone here between 0 to 15 degrees, we have a time of 12 noon. So every city, town, country in this wedge here from the North Pole all the way down to the south is observing 12 o'clock noon. We have to figure out what the time is going to be as we move westward. Again, remember, west is less, and every 15 degrees is 1 hour. This area is observing 12 noon. So that means once I hit 15, I've reached a brand new time zone. And since I've gone west, the time is going to get less. So I've gone 15 degrees, which is worth 1 hour, and I'm going to subtract 1 hour. So this time zone is going to be at 11 a.m. If I continue to travel westward, I get to 30 degrees. Remember, that's two 15-degree lines away. So that's going to subtract 2 hours from our original starting point. So this time zone will be experiencing 10 a.m. And as I get to 45, that means I'm 3 sets of 15 degrees away. So that means I'm going to subtract 3 hours from my starting time of noon, and that's going to give me a time of 9 a.m. And as we go, every time zone, we subtract 1 more hour. That's what happens, or that's how we determine time as we go west. Now, as we go east, time increase. If I start here in this zone and I move over to the next time zone, I'm going to add an hour. This time here would be 1 p.m. And then as I move to this time zone here, my time will be 2 p.m. Every 15 degrees that I move over, I keep adding a brand new hour. And as we move around, we'll see that we eventually will get to midnight at the international date line. That's how our time zones are broken down, and that's how you can figure out whether you have to subtract and how much you have to subtract, or whether you have to add and how much you have to add time when you're figuring it out. Now, last point I want to make is this. What you'll notice is that the international date line is located here at 180 degrees. The international date line, again, is the main starting point of the new day. So as you can tell, this time zone here has reached midnight. So we're at midnight at the international date line. So midnight starts the brand new day. Here at the international date line, we can start the brand new day, let's say Monday. So we're at midnight Monday morning. But as we move back through this time zone is still experiencing 11 p.m. Sunday night, and then 10 p.m. Sunday night in this time zone, 9 p.m. Sunday night in this time zone, down at noon on Sunday near the prime meridian, and even all the way back here through the U.S., we're still at 5 a.m., 6 a.m., 7 a.m. Sunday morning. You always have to remember that the international date line is the starting point of the brand new day, and every single time zone behind it is still in the previous day. All right, well, that concludes our vodcast and our lesson on time zones. I hope you found that helpful.